Two-dimensional Kamal transform of space of distribution of Boehmians. Abstract. In this paper we have tried to define two-dimensional Kamal transform, namely the double Kamal transform of bounded support, with the help of Zemanian technique. The integrable Boehmian of double Kamal transform is developed using Mikusinkis theory with some of the properties. The double Kamal transform is extended to generalized function. Some properties and distribution sense are obtained and tried to extend this class to integrable Boehmians. Keywords: convolution theorem, double Kamal transform, integrable Boehmian. Introduction. In the field of engineering, the ordinary and partial differential equations plays vital role. To solve the differential equation, integral transforms are used suitably to convert into simpler form and obtain the solutions easily. The double natural transform are studied in 2 to 4, 6 deals with applications of 2 to 4, whereas 9 gives the applications of Kamal transform for single variable functions. The two-dimensional Kamal transform of function of two variables can be used to solve partial differential equations. Definition 1. The Kamal transform for a single variable function of exponential order in the set S equals, where the constant m is finite number, may be finite or infinite, is defined by 1. Kf t equals g v equals. The inverse Kamal transform is. Definition 2. The two-dimensional Kamal transform, namely the double Kamal transform of a function of two variables, is defined by 8 as k2 equals g equals, provided the integral exists and can be expressed in the convergent series on a set A of functions continuous and of exponential order. A equals, where the constant m should be finite number, may be finite or infinite, and v is a variable of transform. Let be integrable functions of two variables. Then by using 7 the double convolution of is given by equals double Kamal transform of bounded support. Let J be compact subset of I equals 0, denote the test function space of all complex valued infinitely smooth function spaces of E, Ixi, such that for k, m are non-zero positive integers. Then E, Ixi, is a vector space under the usual operations. Also D, Ixi, E, Ixi, a sequence, converges in E, Ixi, and for each non-negative k, m, converges to uniformly on every compact subset Ixi. The space E, Ixi, is complete, and E, Ixi, dual of E, Ixi, consists of distribution of compact support. By the definition of double Kamal transform, the kernel is smooth and satisfies 1. For all positive real numbers u, v. Hence for every f, e, Ixi, we define the distributional double Kamal transform of compact support with the help of Zemanian 10 as equals 4. 9i, 2. IJERT 9IS040696 www.ijert.org. Published by International Journal of Engineering Research and Technology, IJERT. www.ijert.org. ISSN 2278-0181. Volume 9, Issue 04, April 2020. Theorem 1. The distributional double Kamal transform is linear. Proof: for any constants c, d we have equals plus equals c plus d. Theorem 2. Let H be distribution in E, Ixi, and let be defined by. Then proof: here is a member of E, Ixi, by translation property. Equals. Theorem 3. Let E, Ixi, and be the distributional double Kamal transform. Then kthth equals and where n are and n. Derivatives WRT x and t. Theorem 4, let E, IXI, and be the distributional double Kamal transform, then proof equals 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 equals. Theorem 5, let E, IXI, and be the distributional double Kamal transform of, then equals proof equals equals equals. Theorem 6, let E, IXI, and be the distributional double Kamal transform of, then 1, 2. Proof, let E, IXI. Then by theorem 3 and equation 2, we have equals 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 equals. Similarly we can prove the part 2. Theorem 7, let E, IXI, and be the distributional double Kamal transform of, then U, V, where H, X, T, is Heaviside unit step function defined by. Prove, by using the definition of distributional double Kamal transform. Equals 4 equals equals equals. IJERT 9 IS 040696 www.ijert.org. Published by International Journal of Engineering Research and Technology, IJERT. www.ijert.org. ISSN 2278-0181. Volume 9 Issue 04, April 2020. Convolution of double Kamal transform. Let be distributions of compact support in E, IXI. We define the convolution of as 3, where E, IXI. If E, IXI. Theorem 8, let E, I11, and E, 9I, if where 1, 2, 3, then is infinitely differentiable, and this result is proved in 11, pp 130. Theorem 9, the convolution theorem if, are distributional transforms of, respectively, then proof equals 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 equals. Integrable Boehmian for double Kamal transform. Let be the space of Lebesgue integrable functions on is the set of positive real numbers, then by 5, a sequence of continuous real valued functions over X is called a delta sequence if and only if 1, 2, k, for some positive k, and all 3, as, for every. The space of all integrable Boehmians is denoted by, which is a convolution algebra with 1, 2, 3. Lemma, if then the sequence k equals converges to each compact set X in X. Proof, we have then its double Kamal transform converges uniformly to the function of U, V. Henceforth, each jxj is positive on jxj and k equals k. 4 equals on jxj i.e. k as, on jxj, 1 as. Now, we will define the double Kamal transform of an integrable Boehmians as 5, where the limit is over compact subsets of X. Thus, we get a continuous function of double Kamal transform of an integrable Boehmians. Theorem 10, the double Kamal transform of an integrable Boehmians is well defined. Proof, let such that then applying double Kamal transform equals from equation 5 and theorem 9. Theorem 11, the double Kamal transform of an integrable Boehmian is linear on compact sets. Prove, let be such that then equals plus also C equals C dot, where C and Theorem 12, Convolution theorem for integrable Boehmians. IJERT 9 IS 040696 www.ijert.org. Published by International Journal of Engineering Research and Technology, IJERT. www.ijert.org. ISSN 2278-0181. Volume 9 Issue 04, April 2020. Let then proof equals Theorem 13, if and dot equals 0 in then equals 0 in prove, let and dot equals 0 then by the definition of we have on compact sets, again by definition of Kamal transform AE in and is 0 quotient of function. Equivalently is 0 equivalence class in Theorem 14, the generalized double Kamal transform is 1-1 mapping from into space of continuous functions. Prove, let equals 0 in Theorem 13. Theorem 15, the generalized double Kamal transform is continuous with respect to congruence. Prove, let as in then the dash for some and as equals as dash dot as results. We have tried to obtain double Kamal transform of bounded support. The linearity property, convolution, is studied in distributional view, and also Boehmian spaces are studied. The convergence and are defined in double Kamal transformation. Conclusions. In this paper, the two-dimensional Kamal transform, namely double Kamal transform of bounded support, is obtained. Also the extended double Kamal transform of distributional space along with some of its properties is studied. The convolution of double Kamal transform of Boehmians and extension of it to integrable Boehmians is derived.